Did you ever try to power up your OrangePi PC or OrangePi One or OrangePi Lite with a power supply which works perfectly for the Raspberry Pi? Well, if you did, you're out of luck. This video will show you why it doesn't work, it'll show you some workarounds, and it'll also talk about the actual power demand of the OrangePi PC. What have we got here? We've got an OrangePi PC Lite, as you can identify by the little antenna over there. And now I'm gonna start out by plugging it into a power supply. I'm using the normal cable which I use to charge my phones. Quite incidentally, I really like this product because it can be inserted both ways, as I will show in the show notes. And you see I'm plugging it in and absolutely nothing happens. Trying to plug it in even better, but still nothing happens. You see, the screen doesn't light up, the thing's asleep. Just for comparison, if I use the power supply intended for this type of process computer, which I've got over here, and I plug it in, we also have to wait a little bit. Shenzhen Zhonglong's products are notorious for their very, very slow startup process. But we see, slowly but surely, it's coming up. Push the power button and you see the screen is already reacting in the background. You can't see it because of the camera angle, which is a bit difficult to adjust, but well, you see here, it's definitely working. For the following steps, I'm using some schematics which show the classic OrangePi PC. I have, however, done some verification, and the other units, by and large, behave the same way. We see here the powertrain. So it says 5 volt DC in, and we see a direct connection to SPDIF, USB host, and HDMI, while all the other ones are regulated. So at least in theory, we should be able to power the unit via the USB host. Why this doesn't work is shown a bit deeper inside the datasheet. Problem number 1 resides here in the form of this diode. We see here the input jack, which I used to power the process computer before, and we see here an ESD protection diode, some capacitors, and here we see another diode, which powers here the VCC. Of course, there's a little resistor here, by the way, but its value is much too high to allow enough current to flow to actually power the process computer. And as if this weren't trouble enough, we see here the DC in 5 volt is not connected directly to the USB host. Instead, we've got a circuit here which acts as some sort of enable switch. In this case, actually, it's quite interesting because we see here that the enable input is connected via a voltage divider, and so the power basically is always coming. As for this IS, the SY6280, finding a datasheet for is a little bit difficult because the datasheet is classified, but I was able to find one. So, if we look into the datasheet of the product developed by Silergi, incidentally, we see here it's a current limited MOSFET power switch and there is no parasitic body diode. So essentially, what we've been imagining is not possible. The USB port or the MicroUSB port cannot be used to power the process computer under any circumstances. Fortunately, there is quite a nice workaround in the form of the 40-pin GPIO header. If we look carefully, we see here that the pins 2 and 4 are connected to DC in 5 volt, while the pin number 6 is connected to ground. And so we can, at least in theory, but also in practice, power the process computer via these two pins. There is one very important thing to observe, however, when doing this. Whatever voltage you apply to DC in 5 volt gets fed directly to all the attached USB hardware and similar stuff. So if that voltage regulator isn't of good quality, you can easily toast your attached circuitry. Bringing this concept to life is not particularly difficult. You see here I've been using the normal breadboard female connectors to connect to the OrangePi. The only thing which is important is this little triangle which you see here at the bottom. This one indicates where pin number 1 is, and the pins you need are behind. This what I'm showing you here is for the OrangePi 1 and for the OrangePi Lite. With some of the other OrangePis, this is turned around by 180 degrees. Well, as for where the power is coming from, basically you have your choice. I'm using an HP 6624A power supply because it provides us the ability to see how much current is being drawn. You could of course also grab any random wall wart, cut its cable in the middle, solder on these two little things, and then you could power the OrangePi essentially from a wall wart. But now let's get booting up. The current limitation is set to 0.5 amps. The voltage limitation, I'm setting it to 5.7 volts. I know that this is too much. However, you need to compensate for the current losses in the cable if the Kelvin protection isn't enabled, as it is in this case here. So now I'm pushing the start button, and we see power is being drained as the process computer starts up. Starting up, tada, and we see 200 milliamps, 240, and now the screen has come on. Now we're in the range of about 30-34. At this point there's something very important. If the process computer is not able to enter into the user interface, if it crashes at the point which we've just seen, then you've got a problem related to the voltage. If the supply voltage is too low, you cannot get into the GUI, or you experience a hang when entering into the GUI in a fashion similar to what you are seeing right now. But as this is only for an experiment, we let it be. As for reliability, I am basically using a circuit like that based on the 2575 fixed voltage regulator for quite some time. I've got like a dozen of these controllers deployed, and I haven't had a single problem with them, even with an externally attached USB stick or similar module. So, in principle, powering the OrangePi family is not as difficult as it sounds. I hope that you've enjoyed this video. Hope to see you again soon, because there's so much more to learn in 10 minutes of electronics.